Now let's finish discussing the other options that are available to us under the XY tab. We've already discussed resolution. We will, in a few minutes, go back and select some very high resolution images, and we will do line averaging and frame averaging to get the better images from these resolutions. So we'll come back to that in a second. For now, let's leave it on 512 by 512. We also have a pinhole feature that allows us to change the size of the pinhole, and I'm going to show you how that affects your image in a second. Remember, the pinhole in the microscope is used to eliminate extra light that is being produced as a result of the laser excitation. The laser excites all the fluorophore that is present throughout your tissue. If you allow all that light to come back to the observer or back to the camera, it will be too much information and you will not be able to resolve your structures, let alone the molecules that you're interested in watching in live processes. So therefore, it's important to use a pinhole to eliminate that stray light and give us a nice clean optical section of the image that we're looking at. The system is always defaulting to a standard pinhole that gives optimum results for the objective used, the fluorophores used, etc. But as is everything else in this software, the pinhole can be manipulated. It's not recommended that you play with the pinhole, but in some instances where you do not have enough illumination returning to the camera, you may want to widen the pinhole. And so if you look down here at the bottom of this tab that opens up when you click on the pinhole, that opens up for you, and now you can change the size of your pinhole. The smallest size of the pinhole is down around 20 to 30 microns in diameter, but you can increase that all the way up to over 500 microns, which is certainly not recommended. This would be no better than a standard fluorescent microscope. The whole point of the pinhole, and there's actually two pinholes, one that you can manipulate right after the illuminator, and another one that's inside the microscope, which you cannot manipulate. The whole point of the pinholes is to give you the sharpest high-resolution image as possible. So we will play with the pinhole a little bit, and I'll show you the difference in the illumination when we do that. Note also that the system gives you the ability to select the size of your pinhole in microns or in area units. We're not going to take the time to discuss area units right now. Basically, one area unit is comparable to about 61 microns. And that's sort of a standard that's selected in the industry for resolution. But realize that your pinhole can go all the way down to about 30 microns and all the way up to about 500, which we discussed before. Now remember, the important thing about a confocal microscope, and the feature that makes it distinctly different from regular compound microscopes, are the pinholes that are in the microscope. Think of the diaphragm that we use in the condenser to give us contrast and depth of focus on a bright field image. If you're looking at unstained cells through the microscope, in order to achieve contrast and depth of focus, you close down that iris diaphragm in the condenser, and that brings your cells more crisply into view. The same principle is applied with the pinholes in the confocal microscope. And there are two pinholes, one that is adjustable and one that is fixed, that allow us to eliminate extra light that we're not interested in and only give us light in an optical section, so we get the crispest images of a thin optical section of our tissue. One of the special features of a confocal microscope is the fact that it has pinholes in the microscope to achieve very high resolution images. Think of the iris diaphragm that you have in your condenser on a regular optical compound microscope. If you're looking at unstained cells, you have to close down that iris diaphragm in order for those cells to come crisply into the field of view and to maximize your depth of focus. You cannot see those cells until you close down that iris diaphragm. The same principle generally applies to a confocal microscope. It uses two pinholes, one of which is fixed, the other which is adjustable, which eliminates light from above and below the region of interest that we're looking at. And it allows us to make a thin optical section in very high resolution of only the information that we want to see. So that's what distinguishes a confocal microscope from a regular upright compound microscope.